Problem 4. A spinner can land on the numbers 10, 12, 14, and 16 only, and the probability of the spinner landing on each number is the same. The random variable x represents the number that the spinner lands on when it is spun once. State the name of the probability distribution of x. Since the probability of the spinner landing on each number is the same, that's why the distribution of x is discrete uniform distribution. Problem B. Write down the value of Ex, or the expected value. So you can see that we have random variables that are 10, 12, 14, and 16. They are symmetrical. And you can see the middle number is 13. So the expected value is 13. The next one is finding the variance of x. So variance x is expected of x squared minus the expected squared. So we have to find the expected of x squared first. The expected of x squared is summation of x squared times its own probability. You can see that we have a spinner with 4 sections here, and each of them has the same probability. That means the probability of landing in each sector is 1/4. So the first one, it will be 10 squared times quarter plus 12 squared times a quarter plus 14 squared times quarter plus 16 squared times a quarter, which is 174. So now we can find variance, which is 174 minus expected value squared, which is 13 squared. So the answer is 5. That's the answer. Here's the next part. A second spinner can land on the numbers 1, 2, 3, 4, and 5 only. The random variable y represents the number that this spinner lands on when it is spun once. And here is the probability distribution of y. So the first one, we have to find the expected value of y. The expected value of y is summation of y times its own probability, which is 1 times 4 over 30 plus 2 times 9 over 30 plus 3 times 6 over 30 plus 4 times 5 over 30 plus 5 times 6 over 30. You can factorize 1 over 30 over here, and it will be just 4 plus 18 here plus 18 here plus 20 plus 30. And the answer is 3. So expected value of y is 3. For variance of y, it is expected value of y squared minus the expected value of y squared. So first of all, we have to find the expected value of y squared, which is 1 squared times 4 over 30 plus 2 squared times 4 times 9 over 30. We keep going the same pattern. 3 squared 6 over 30 plus 4 squared times 5 over 30 plus 5 squared times 6 over 30. And the answer is 10.8. So that means the variance of y is 10.8 minus 3 squared, which is 1.8. Next, the random variable w equals to ax plus b, where a and b are constants. And a has to be greater than 0. Given that EW equals to EY and variance W equals to variance Y, and we have to find the values of A and B. So first of all, we have to find EW, or the expected value of W. And according to this one, we know that expected value of W will be E of AX plus B. A times EX plus B. From the previous problem, we know that EX is 13. So this one will be 13A plus B. And from the information, we know that EW is the same as EY. So that means this one is also EY. And EY is 3 from the previous problem. Here is the first equation. Well, let's move on to the next part. Variance W is variance AX plus B, which is A squared variance X, and variance X is 5. Now we have 5A squared. Since variance W equals to variance Y, and variance Y is 1.8, So this is our second equation. And from the second equation, we can solve for a. So a squared will be 1.8 divided by 5, which is 0.36. So to find a, we have to square root 0.36, and it will be plus minus 0.6. But since a has to be greater than 0, according to the problem, that's why we know that a is 0.6. We substitute a back into this equation in order to find b. So b will be 3 minus 13a, which is 3 minus 13 times 0.6, which is negative 4.8. So the values of a and b are 0.6 and 4.8. That's the answer. Here's the last part of question 4. Each of the two spinners is spun once. Find the probability of W equals Y. And since we know that W equals to AX plus B, and we've just got A and B from the previous problem, so we can rewrite W as 0.6x minus 4.8. Here are the values of X. We have X equals 10, 12, 14, and 16 according to the problem. So now we can see that when x is 10, W will be 0.6 times 10 minus 4.8, which is 1.2. And when x is 12, W will be 2.4. And when x equals 12, we do the same process. So W will be 2.4. When x is 14, W is 3.6. And when x is 16, W is 4.8. Let's see the values of y. Y varies from 1 to 5. And now you can see none of W equals to y. So that means probability of W equals y is 0. Here is problem 5. A company director wants to introduce a performance-related pay structure for her managers. A random sample of 15 managers is taken, and the annual salary was recorded for each manager. The director then calculated a performance score for each of these managers. The results are shown on the scatter diagram in Figure 1, which is right here. And we have to describe the correlation between the performance score and annual salary. So as you can see from this trend, we know that the trend is pretty much positive. So the answer is positive correlation. So we can answer positive correlation for this problem. The results are also summarized in the following statistics. We have to show SXY. So first of all, we write down the formula of SXY. We can see that SXY is summation XY minus summation X times summation Y divided by N. And the summation XY is given, which is 19,428 minus summation X, which is 465 times 562 divided by N, which is 15. The answer is 2006. And next we have to find SYY. The formula is SYY equals to summation of y squared minus summation of y squared and divided by n. Summation of y squared is given, which is 23,140 minus summation y squared 562, we square it and divide it by 15. So the answer is 2083.73. We can round it to 2080 for 3 significant figures. Next, we have to find the product moment correlation coefficient between performance score and annual salary. R is SXY divided by square root of SXX times SYY, which is 2006 divided by square root of SXX, which is 2492 times SYY, 2083.73. And the answer is 0.8803, 104. We can route it to 0.880 for 3 significant figures. The director believes that there is a linear relationship between performance score and annual salary. We have to state whether or not these data are consistent with the director's belief. And according to R that we've got from the previous problem, R is 0.88, which is closer to 1. That means it is strong positive correlation. So the data are consistent. Now in problem E, we have to calculate the equation of the regression line of y on x. So here is the formula of B. B is SXY divided by SXX, which is 2006 divided by 2492. So the answer is 0.80497. Now we have to find A. A is y bar minus B x bar. Now we have to find y bar first. Y bar equals to summation of y divided by n, which is summation of y, 562. So we have 562 divided by 15, which is 37.46. And now we have to find x bar too. X bar is summation x divided by n, which is 465 divided by 15, and the answer is 31. Now we put it back into this formula, so this one will be 37.46 minus B, which is 0.80497, and then you multiply by 31, and the answer is 12.5081, which is 12.5. This one you can route it to be 0.805. That means y will be 12.5 plus 0.805x. Problem F. Give an interpretation of the value of B. B is the gradient and it's in terms of 1,000 pounds. So that means 0.805, you can estimate it into 800 pounds. And since the gradient is positive, that means the rate, in this case, has to be the rate of increasing of the annual salary per one performance score. So we can say that every performance score gives an extra 800 pounds in salary. And next we have to plot the regression line on a scatter diagram. Y is 12.5 plus 0.805x. Now you can see that when x is 0, y is 12.5. So we can label 12.5. That's 12.5. And then you can substitute x equals to 50. If x equals to 50, y will be 12.5 plus 0.805 times 50, which is 52.8. So 50 and 52.8 will be around here, like almost at 3. And then we can draw a straight line like from here to here. And since our data is around here, that's the minimum data, that's the maximum data. So our x data varies from 9 to 50. So we have to erase this part. Here is problem H. The director hears that one of the managers in the sample seems to be underperforming. Circle the point that best identifies this manager. According to this diagram, you can see that this point seems to be the one that is underperforming. So the answer is this point. Next, the director decides to use this regression line for the new performance-related pay structure. Estimate to 3 significant figures the new salary of a manager with a performance score of 30. You can see in our regression line here, x starts from 9 to 50. That means to estimate 30, it is an interpolation. So we can estimate it. And we are going to substitute the performance score, which is X, into this formula in order to find the salary. So 12.5 plus 0.805 times 30. And the answer is 36.65 in £1,000, which is 36,650, which can be rounded to £36,700 for three significant figures. Here is problem 6. A disc of radius 1 cm is rolled onto a horizontal grid of rectangles so that the disc is equally likely to land anywhere on the grid. Each rectangle is 5 cm long and 3 cm wide. There are no gaps between the rectangles, and the grid is sufficiently large so that no discs roll off the grid. If the disc lands inside a rectangle without covering any part of edges of the rectangle, then the prize is won. By considering the possible positions for the center of the disc, we have to show that the probability of winning a prize on any particular row is 1/5. You see that we will have a grid of 5 cm and 3 cm. And according to this diagram, you can see that the center of the disc has to be at least 1 cm away from the sides. So no matter where it lands on, like here, 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 or here, it leaves some space in, like from here to here, it will be 3 centimeters because the radius is 1, that means the diameter is 2. And from here to here, this is 1. And you can see that if we have this space left in the grid, if your disc has landed in this grid, the probability of winning the prize is the area of 3 times 1 divided by the area of the whole rectangle, which is 5 times 3. That's the probability of winning the prize. The answer will be 1/5. Next, a group of 15 students each roll the disc onto the grid 20 times and record the number of times that each student wins a prize. The results are summarized as follows. Find the standard deviation of the number of prizes won per student. In this problem, variance x equals to summation x squared divided by n minus x bar squared. The summation x squared is 295 divided by n, which is 15, minus summation x 61 divided by n, which is 15, and then we square it. 3.1288. So to find the standard deviation, take square root on 3.1288. And the answer is 1.76886, which is 1.77 for three significant figures. A second group of 12 students each roll the disc onto the grid 20 times, and the mean number of prizes won per student is 3.5 with a standard deviation of 2. Find the mean and the standard deviation of the number of prizes won per student for the whole group of 27 students. Here is the information from the first group. And now we have the second group, so we are going to label it as Y. And Y, in this case, we've got 12, and the mean is Y bar, which is 3.5. Standard deviation of Y is 2. We have to find the mean and the standard deviation of the number of prizes for all of them. So I'm gonna let Z equals to X plus Y. So that means Z is the random variable represents the total of 27 students. Now we know that we can find Z bar, which is summation X plus summation Y divided by 27. Since we don't know summation Y, from here summation Y is n times Y bar. 12 times 3.5, which is 42. Now we can find Z bar. Summation x is 61 plus 42 divided by 27, and the answer is 3.81 for it, which is around 3.81, three significant figures. And next we have to find the standard deviation of these 27 students. sigma z will be summation z squared divided by n minus z bar squared. Now we have to find summation z squared. So this one will be summation x squared plus summation y squared divided by 27 minus z bar squared. So we can see that summation y squared equals to something. So we have to find it from here. Variance of y will be summation y squared over n minus y bar squared. The variance of y is given, which is 2 squared. So 2 squared here equals to summation y squared over, this n has to be ny, and ny is 12. So we put 12 here, minus y bar squared, which is 3.5 squared. We rearrange and make summation y squared the subject. Summation y squared equals to 195. And then we put it back into this formula. Summation x squared is given, which is 295. So we put 295 here, plus 195 divided by 27 minus z bar squared, which is 3.8148 squared. And then we put this in the calculator, so it'll be 1.8961, which is around 1.90 for 3 significant figures. Here's come to the last problem. The 27 students also recorded the number of times that the disk covered a corner of a rectangle, and estimated the probability to be 0.2216 to 4 decimal places. Explain how this probability could be used to find an estimate for the value of pi. Explain how this probability could be used to find an estimate for the value of pi, and state the value of your estimate. This is the grid. To land on the corner, we have 4 possibilities here. If we consider in this grid, you can see that the area that we wanted is this one, this one, this one, and this one. Each area is a quarter of the whole circle, which is pi r squared. And since the radius is 1, each area at the corner will be 1/4 pi. Now we can see the total area is 4 times 1/4 pi, which is just pi. And this total area is the area that a disk will land on a corner. And this area will be the area that a disk will land cover a corner. The probability of landing on a corner is 0.2216. And according to this diagram, the probability of landing on a corner is pi over the area of the grid, which is 5 times 3, which is 15. And since these two terms are the same, that means we can equate them. Pi 5 over 15 equals to 0.2216. So that means pi will be 0.2216 times 15, which is 3.324. And since this one is an estimation, 3.324. And the explanation would be the center of the disk must be within 1 centimeter from a corner.